Hi, my name is Robert Ebelher, and today I'm going to be telling you about the architecture for my password store program. So the main functionality of the system is basically providing users with access to account-only services, and this basically means that a user is going to be required to register and/or log into this system before they gain access to certain functionalities that the system will provide. Some of these main functionalities that will be provided is the ability to store hard to remember account information such as login names and passwords. It is also going to be able to give the user the ability to retrieve, update, remove those saved login names and passwords. Of course, all this information will be securely encrypted to prevent data spills and will be stored on a database. The system will also provide unique password generation, um, which will be determined meeting certain criteria for the form. So this is my first architecture option, which is the client-server architecture, and this is the level 2 diagram. And basically here we have a database which talks to a server using a JDBC connection, and then we have a client which will be talking to a server using a RMI connection or a remote method invocation connector. And basically you can see for example, inside the server we have a class which is login implementation class. This class will be passed to the client using this RMI, and basically once the client is logged in successfully, once it's verified through the database, the client will be passed a product interface. So there's a login interface and there's a product interface that the client has access to, and the actual implementations are on the server side. And so basically once the user is logged in, the product will be used for the GUI components of the client, and then on the server side the product implementation will talk to a database manager, which will also in turn talk to a table manager, which will be the main fronting point for the database table connections. So my next slide is the client-server architecture again, but this is actually the class and connector representations here. I didn't go into details with actually classes, UML diagrams, because there's so many classes and it's too hard to fit everything in on the slide. So I just went with the class names here and the relationships there. So again, as you can see, we got the database on the left side, we have the server in the middle, and then the client the far right side. So if we start with the server, you can see the connector component there, which talks to the database, and you can see we have two table managers. We have a user table manager and then a password info table manager. These both talk with the connection to the database, and then we have a database manager, which these two table managers talk to. And if we look up here, we see we have this login implementation class, which I talked about in the last slide, which is retrieved by the server and passed to the client using this remote method invocation connector here. We also have the server utility class, which is basically used throughout the server. Different utility methods there. Forgot to mention the legend here. You can see the cloud things, which are these two things, are the component connectors. And then if you look at this double rectangles here, these are actually the interfaces, and I tried to show those. So we have a login interface and a product interface. But in this middle section here, I tried to put the classes that are shared between server and client. So these are the classes that are shared between them. So server has access to the user class and also client. Same with server exception, and these two login and login and product interfaces. But of course, once client has access to this login interface, it basically brings up the login controller, which in turn brings up the login view, which basically displays the first page, which is the login view page. From this page, you can get to the register view page basically through the controller. Then once you're actually successfully logged in, you can get to the menu controller or menu view page through the controller here. And this is basically just a network of all the controllers and views for the graphical user interface that client uses. In turn, all these controllers will have access to product, making the calls to the database backend and the server functionalities once a user is actually logged in. And you can see the relationship here as everything ties back to the database manager, because most of the data will be coming from the database. So my next architecture is the event-based architecture. This is the level 2 architecture diagram. You can see here we have a producer, an event bus, a consumer, and a database. So going left to right, we have the producer. Inside the producer, we have a producer manager class, and then we have a bunch of event classes. So the producer interacts with this event bus, which has an event manager class and then a database manager class. Of course, the database manager class will interact with the database. Then we have a consumer. We have a consumer manager, and then we have all the GUI component classes as well. So again, event-based architecture, this is the class and connector relationships here. Producer, event bus, consumer, again, left to right. You can see the producer manager class component here, and you can see how it ties in with all these events here on the left side. We have the login, register events, storing, retrieving, deleting, updating, generating password events here. So all these will be passed to the event manager inside the event manager bus, which will in turn interact with the database manager and the two tables here, two table managers here, which will retrieve and push data to the database as needed. And then we have our consumer manager, which will get the data, the functionalities needed from the event manager, pass it to the consumer manager. And basically all this here is just the graphical user interface components here and the interactions between them. So the client server architecture, pros and cons. So the pros. This architecture has increased performance because if you have a high load on the system, all you need to do is buy a new machine for wherever the server is sitting on, because it makes it really easy to upgrade. You don't have to upgrade your code. You can just upgrade the machine it's sitting on. Also, ease of effort and maintenance. Since it's broken down into a server and client components, basically, if you need to ever make changes to a client, you can just update the graphical user interface there, which will in turn not affect anything on the server side functionality wise. Also, security, whatever server your code resides on, you have the ability to control access and resources for that server. So the cons, the impact of centralized architecture. This basically means if the server or the database, if either one of those ever crashed, the architecture or the application would fail, because we need to talk to the server to gain the functionality for the client. So in those cases, our application would not ever be able to run if those two things ever failed. So the event-based architecture, pros and cons. Pros, this architecture is very flexible. New events can be added in the future with little impact on the system, which makes it really nice when we want to add new functionality. We just add a new event, so that would be pretty simple. It's very suitable for graphical user interfaces, like we're doing here. Lots of windows and such, so it makes it good for that. And the ease of development. So this means managing of one control at a time. So basically you program one event and you see it all the way through its complete implementation. The cons of this, it's a pretty big con. Security. Other programs, if someone knows how to, gain access to your events, subscribing to the events, you could, with this system, you can steal important data. Like since we're dealing with passwords and user logins and passwords, possibly bank account passwords. I mean, that's a huge concern here. If someone was able to steal those using this architecture. So my decision was basically to use the client-server architecture, and the rationale behind this was mainly we needed a secure system to deal with the handling of the user login and password information. And with the event-based architecture, it would leave too much risk for another program to hijack this important user information. So that was the main rationale there. But some other ones, as more users use this system, I can easily upgrade a system by just upgrading the machine that the server and the database reside on. Another thing is that the GUI, if I ever want to overhaul the GUI, make it prettier, I can do that very easily without worrying about making any changes to the server side and the back-end database stuff. I just need to worry about changing the windows and stuff like that. All the functionality will still be in place. So for the demo, first I'm going to show you the database side of things. Basically, here's my schema, password store. I have two tables in this schema. I have a password info table. This table basically will house all the users' password info, such as their login name and their password. And then the other table is this user table, which is going to store the login info for the user so they can actually gain access to the system. So we can see here first, this user table, we have a user column, a name, and a password, which is encrypted, of course, single encryption, one-way encryption. We have the email and the name of the user. The second table here is this password info table. We have no records in it yet, but I will show you that here in a second once I run the program. You can see we have a storage title, the email, which ties back to the user table. We have a login name, password, and description. And I will show you this as I demo the program. So let's get into the demo. So of course, first here we want to start out the server. So let's go ahead and run the server. Server's ready. Next we'll start the client. Let's start the client. There we go. Alright, so we're going to log in. Since I have one user in the system already, I don't need to register, but I will show you the registration process as well. So the first user is this admin I've created. So let's go ahead and log in here. So this is basically, there's not much to the GUI. I don't want to spend too much time on it, but I basically want to show you this is the menu page. We can click here. We can see we have different options here, such as delete, generate, retrieve, store, update. Currently, I've only got the store functionality working because I just wanted to test the framework of talking to the database, putting data in the database, and getting data from the database and the server-client interactions. So we'll go to store functionality. So basically, simple form here. We're just going to fill it out real quick. Call it demo, login name. So just put some stuff in here. And then we're going to go ahead and store it here. We get this screen, shows that the password info was stored successfully. So if we were to go back, look at our database, look at our password table, info table, we'll go ahead and refresh. We can see we have a new record in here. Storage title, demo, email, which admin@hotmail.com. If you remember, that was the user we logged in with, which ties back to this table, ties back to that email there. Here's our login name, here's our password, and here's our description. Of course, I did not encrypt the password or the test login name or the login name because I wanted to show you guys for the demo. You can see actually that everything's getting stored properly. Now let's test the registration piece of this. So I'll go ahead and start since the server's already running, it's still running, I'll just start the client up again. Let's kick that off. Now I want to register. I want to create a new user. So let's create this new user. Call him Rob Ebbleher. Put an email in, okay, let's say one test here, let's say we put in a bad email. Let's say I forget the @ sign, I just try to do that. Put in some password. If I try to submit, it's going to give me this error. You know, so this is simple client stuff, validation form stuff. So this is all stuff that's actually on the client side of things. But let's go put a valid email in, and then a valid password. We'll submit. So since I registered, I don't have to go back to the login page. It just goes ahead and takes me to the main functionality, this menu page. We'll go back to the store. We'll store something else. Alright, we'll store it. Again, it was successful. So let's go look in the database. So first, let's look at the user table. So now if we refresh, we should see this new user, myself, added to the system. Is it going to refresh? Let's see. So this page, so this table refreshed. I don't know why this user table is not refreshing. Let's try it again. Okay. So I guess I didn't commit my last transaction, so that's why it wasn't working. But we're back on the user table. We got a lot more data in here because I tried to clear out. What happened was I tried to clear the data out before the demo, and I guess I didn't commit the transaction. But you can see here, here's our email, rob@hotmail.com, and here's my name, encrypted password, of course. And if we look at the password info table, we can see this new record, which ties again back to the rob@hotmail.com email, and here's all this info. So basically, as you can see, this system basically just mainly implements the framework for the client-server architecture, and most of the rest of the stuff that's going to be done is just getting these GUI components, you know, how I want them, and making the server connect to the database. But the main stuff of the framework is in place, ready to go. So that's good to go, and that's all I have. Thank you.